Here are some quick examples of a few proofs. This claim, if angle A and angle B are supplementary, and angle B and C are supplementary, then angle A is congruent to angle C. So a two-column proof version of this would be that, well, we were told that they're supplementary, and that was given. So I write that and given. Then the next line is that once they're supplementary, that causes them to add up to 180 degrees, because that's the definition of supplementary. Then, because these two things are both equal to 180, they have to be equal to each other. So the measure of angle A plus the measure of angle B equals the measure of angle B plus the measure of angle C. So that's saying that this equals that, and that's called the transitive property when we say those two things are equal. Subtracting angle B, the measure of angle B from both sides, gives us the measure of angle A equals the measure of angle C. And the congruence postulate says that angle A is congruent to angle C. So that's an example of a proof to that statement. Some of the rules that we use over and over again are listed here. So Euclid's fifth postulate says that when we have two parallel lines that are crossed by a transversal, then that means that the all same side interior angles add up to 180 degrees. So these two make 180 degrees. The congruence postulate says that if I have two angles that have the same measurement, then they're congruent. Also, if two angles are congruent, then they have the same measurement. So it goes both ways. Congruent angles, same thing as having the same measurement. Same measurement. This is about the numbers. This is about the actual angles. The segment addition postulate, we went through that before, but that's the idea that if we have A, B, and C, then that causes AB plus BC to be equal to AC. And the angle addition postulate requires a little more diagram. So this is, if this is A, B, C, and then that's the vertex P, then that implies that the two small angles add up to the whole thing. So the measure of angle APB, that's the first small angle. The second small angle, BPC, they add up to the whole thing, which is APC. So now two examples of proof. Given that they intersect at E, then the angles are congruent. So first I want to identify which angles I'm talking about. That angle is here. This angle is here. So typically I'll rewrite the given. And I'll say that it is given. The next piece, well, I noticed that these two make 180 degrees together. So I will say that they are supplementary. AEC. And what was this? This is CEB. Are supplementary. And the reason is that they make a line. They're a linear pair. So this is the definition of linear pair. Now, that angle and the blue angle are also supplementary. So CEB, and what is that? BED. They're supplementary. And that also has the definition of linear pair as the reason, so I don't have to rewrite that. The last statement was from here, that if two angles are supplementary and a third angle is supplementary to one of them, then it's congruent to the first thing. So here, they're supplementary to the same angle. The same angle. So that means that AEC is congruent to angle BED. last proof here. If the lines are parallel, so that symbol means that they're parallel. So let me mark that, they're parallel. Then we want to prove that those two angles are congruent. ABC is congruent to HBF. HBF. So ABC, well, first I want to say that the angles, the lines are parallel. They are parallel, and that's given. The next thing that I know is that ABC is a linear pair with that angle, which is ABF. And ABF are supplementary, and that's because they're a linear pair. Definition of a linear pair. Now, in order to connect this angle to the blue angle, I want to use Euclid's fifth postulate. Euclid's fifth postulate was, again, this, that if there are lines that are parallel, then their same side interior angles are supplementary. So, HFB and angle ABF are supplementary, and that's because of Euclid's fifth postulate. And now, once again, we have two angles that are supplementary, two angles that are supplementary. So because they're both supplementary to ABF, then they must be congruent. Angle ABC is congruent to angle HFB, and that's because they're supplementary to the same angle. And which angle are they both supplementary to? They're both supplementary to angle ABF. That's what some proofs look like. It is worth noting that not all proofs look the same. This one had some algebra in it. This one used Euclid's fifth postulate, so that was one of the things listed here. And sometimes we have to use definitions. There's a lot of creativity involved in proof, and when you get a proof, there will be similarities, like this is very similar to this, but there are definitely differences, and you have to know these rules and your definitions and your algebra in order to create a proof. Thanks.